Uh, uh, Hello, everybody. We are testing yet another camera angle. This time, I wish maybe I will give you some pictures of the different setups I've been trying. We have one concurrent viewers. Thanks for joining. Say hi in the chat if you will, if you want. That person left. Yeah, I'm trying yet another angle, and this time around, if you can see the monitor, where is my head? Okay, I this table is not quite big, so the laptop and the monitor are kind of compressed, cluttered, but it's still good. I mean, the space here is enough. I was trying yesterday. I put the camera, the laptop behind the monitor. It was funny because I tend to do this a lot to the monitor when I try to concentrate or to see even better. And if the laptop is behind the monitor, then you won't be able to see me, which is silly. Right now there's this uh, this over here, so okay, let's get started. As always, 2 minutes wasted of your time. Sorry. Um, I didn't want to read this on my own, so we will read it together. The last 9 days ago, we ended with exercise 5.7. Then I went crazy with some other videos. So now we are back to this series. Note that these implementations are incremental, they don't fully generate their answers. It's not until some other computation looks at the elements of the resulting lazy list that the computation to generate the lazy list actually takes place. And then it will do just enough to generate the elements. Because of this incremental nature, we can call these functions one after another without fully instantiating the slots. Let's look at a simplified program phrase for a fragment of the motivating example we started this chapter with. Yeah, I remember this. We'll convert this expression to a list to force evaluation. Take a minute to work throughout these traits to understand what's happening. It's a bit more challenging than the trace we looked at earlier in this chapter. Remember that a trace like this is just the same expression repeated multiple times by one more step each time. Okay, they have a lazy list and they apply the map function to stem filter even numbers and then to list. Comes what's going on? Oh, they are applying this. Okay, so the first one is 11, then is list, the one map, again the same map, and filter is still over here. Like, okay, this is good. Some people, the other day I was reading some Java, and this thing came into place in which if filter waits until the end of the map application. In here, you can see that it goes directly with applying the map over the one element and then it goes directly to filter without traversing the entire list. I think I'm going to take a look again at that section in that Java book because it was kind of I didn't get it in the Java. Well, I of course I get it, but I have this tendency to go deep, which is not a good thing. Believe me, you need to move fast, but I am too slow. I don't know how to fix that. Maybe I am too reflexive, as Peter Norvig will say that sometimes it is a good idea to reflect on your problems, but it seems like the industry doesn't. At least, I don't know. Perhaps you so those companies I haven't. Of course, my world is too small. Lazy list with okay, it goes directly to. I'm not playing the victim card. Victim card. 6 minutes. I don't know how to get into speed again as I was doing 10 years ago. But for me, it's okay to be this reflective. Lots of reflection, lots of thinking. The changes only happens with actions. Okay, so the like matter to the first element, then like filter to the first element, like matter to the second element, like filter to the second element, and produce the first result. Mm. Dun, 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 bum, 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 bum. That's an oldie. Um, Nail Diamond is from people from the 70s. I'm not from the 60s or 50s, but I like that those songs from the back in the day. I wasn't even born, but it's are good songs to me. Okay, so they go to the 14, place the list map, filter. Okay, good. Apply filter, and no more work to do, and the empty list becomes the empty list. The thing to notice in this trace is how the filter transformation interleave. The computation alternates between generating a single element of the output map and testing the filter to see the element is divisible by two. Note that we don't fully instantiate the intermediate lazy list that results. It's exactly as if we had interleaved the logic using a special purpose loop. For this reason, people sometimes describe lazy lists as first-class loops, whose logic can be combined using higher functions like filter. Alright, since intermediate lazy lists are instantiated, it's easy to reuse existing operations in novel ways without having to worry that we are doing on the lazy list unnecessary. For example, we can reuse filter to define a to define find a method to return just the first element that matches if it exists. If it exists, then the filter transforms the whole lazy list. That transformation is not lazily, so find terminates as soon as match. As a match is found, I heard this find and there is a predicate option A, filter P, option. Okay, let me get this. Find what? Some even number, for example. Option A, filter. predicate, and then the head option. Let's write this. In a minute, hopefully you are not in a hurry. I am not in a hurry. I am unemployed. You know, this is the kind of thing I was telling you. I close my face to the monitor. If the laptop was behind the monitor, you weren't able to see me. Where these? Where should we put? It seems like in the shit. I'm going to place it over here. Just find space predicate Boolean. Why do you think people like Scala? I like Scala. Um, the Scala 3, of course. Sorry, people enjoying Scala 2, Scala 2.11, for example. I like because of the expressiveness. I don't feel very, so people better shut up. We have a problem type. So this you can fix this because it's not finding the type variable a because we are in the object. So this means that in fact this should be in the enum. Oh, we have a lot of things going on here. And it should work now, right? So this is your answer. Whenever they don't put the type over here and the compiler is complaining, it goes with in the enum because in here we have to type in object companion object. The incremental nature of lazy list transformations also has important consequences for memory usage because intermediate lazy lists are generated. There is one book, yet another book I start and I don't finish. How can I fix that? Do you have any advice for me? I have started this year like 10 books and I haven't finished one single book from all those 10 books. And this yet another book called Algorithm Design in Haskell. Yeah, from Jeremy Gibbons. It's a lion in the front cover. The book says that you just don't worry about memory in functional programming. Like functional programming will always well, I'm not sure if always, but most of the time will take more memory, will use more memory from other programming paradigms, and you can start to notice that behavior if you are like a reflective person like me or any other reflective person in the world. You start to observe patterns and see, well, there is a trade-off. You do computation even by observing yourself, your process. Uh, You can say, well, sometimes I'm calculating some arithmetic in my head, and sometimes I'm just retrieving results. And of course, there is one famous computer scientist, Simon Peyton Jones, who already said said it. Lots of people have come to that conclusion. It's okay, don't worry about memory, just don't be crazy about memory in the functional programming realm. There are these compiler guys making insane amount of effort to optimize these programming languages. The code generated from these programming languages. The lazy list requires only enough working memory to store and transform the current. For instance, in the transformation lazy list 1, 2, 3, 4, 1, 2, 3, 4, map and filter. The garbage collector can reclaim the space allocated for the 11 and 13 immediately. As soon as filter determines they are needed. Of course, this is a simple example. Another but this is the JVM. You know, you don't, you're never quite sure. Most likely, this is the case. In other situations, we might be dealing with a larger number of elements. I think I'm going to make a video on advices so people don't get into the same mistakes as I did in my career academic. I have I have done too much exploration. I forgot that our life is limited. Explore too many topics. I don't regret it. Determines of course, this is a simple example. And these days, it seems like people doesn't value knowledge because it's becoming a commodity. In a situation, we might be dealing with larger number of elements, and later these elements themselves could be lost subject to everything. Being able to reclaim this memory as quickly as possible can cut down the amount of memory required by the program. We'll have a lot more to say about defining memory efficient streaming calculations. There are some things that you can do about memory, but don't worry that much. But of course, there is something to do, as they are saying here. In the part 4, do you think we will be able to arrive at, until that point? The book is becoming challenging. We progress in chapters. We'll have a lot more to say about the final streaming calculation, in particular calculation that require I/O. Infinite lazy list and core recursion. I probably will do a video on recursion because they are incremental at 45%. Because they are incremental, the function we've written also. Because they are, let me see if you are still hearing me. 20 minutes. Probably this data is only for two. No one sees these videos. Because they are incremental, the function we've written also work for infinite lazy lists. Infinite lazy lists. Here's an example of an infinite lazy list of ones. And it is all ones, lazy list, int, type int equals lazy list, ones, one, ones. Okay, let us write this. Let's go over here. We need to clean this because we already tested all this stuff. We can go once. There is a song by YouTube called One. Let's start. Let's type in equals lazylist.com. Oh my god. One, yeah, that's the song. I wish I can play that song for you, but I don't get in trouble. Okay, this is great. Although once is infinite function we have written some expected function of the lazy list needed to generate the demanded output. Although once is infinite, the functions we have written so far only inspect the portion of the lazy list needed to generate the demanded output. For example, take 5. Let's try that. Once, take 5 to list one. Okay, one. Okay, exists. Okay, try playing with the other gun. No, you play it. Once map. Uh, um, okay, once map. It will sum one to everyone. Exist. Uh, even number. They all will be two. They while all you know these are three different expressions, computations. There is no point over here, so don't get confused. In this case, we get back our result immediately. Be careful though, since it's easy to write expressions but never terminate or aren't stack safe. For example, once for all, we forever need to expect more of the series since it will never encounter an element and allow us to terminate with a definite answer. This will manifest as stack overflow rather than. It's possible to define a stack safe person for all using an ordinary recursive loop. But the list is infinite. How can these people uh, be able to do that? You know that it will be recursing, but it will be a stack safe. Probably they will use a tail recursive. Each other one. An infinite lazy list. Once is a lazy list that refers to itself. It generates an infinite series of ones equals ones. Ones take three. Ones, one. Six, three. Expressions that only evaluate a finite number of elements can accept labeled as input. Many functions can be evaluated using finite resources, even if their inputs generate infinite sequences, and infinite lists. Let's see what other functions we can discover generating lists. And finally, we arrived at the exercise find 5.8 after 25 minutes. So imagine someone seeing this video in their recommendations and knowing that this problem is like a small problem, seeing that it would be like 40 minutes, 50 minutes, and will say, oh, how can this person takes an hour to solve this? That person would know that we spent some time reading and enjoying the book. What's the point of me just arriving to write this function? You need to see the struggle. I want to inspire people. Probably I should inspire people by finding a job first. That would be a lot of inspiration for people, I suppose. Okay, generalize once slightly to the function continually, which returns an infinite lazy list of a given value. And then they provide us with the type signature because when I see this just 2 minutes ago, I was thinking, well, shall we use symbol because this val evaluates the thing only once? We can put this object, companion object, we can put it outside, doesn't matter. Let us see how, how the thing goes. We need to return my lazy list, my lazy list. What's the problem? Generalize once slightly to the function continually, which returns an infinite lazy list given value. So we cons the A with continually A, but somehow I think we are missing something. A lazy list because here we are outside. Let us see if this compiles. Yes, let's put this continually. Which number do you like the most? I have a pending video in my mind. I have lots of ideas throughout the day and weeks. I want to make a video on numbers. What are exactly numbers? This, of course, has been discussed like forever. But I want to, you know, it will be in Spanish. Um, I will put some symbols from across the cultures, the number those symbols represent, and how these things are just symbols, figurines, figurines, drawings to communicate. Let's go with 100. Let's take five of those 100 and let's do transform this into two leaves. 100, 100, 100, 100, 100. This is the end of this streaming. Thank you very much. I'm going to save this URL for the next video streaming. Have a nice day. 4 p.m. That's amazing because now we can, uh, like, I don't know. I have too many. I don't even know. Probably I will play the guitar. I'm not sure. I wish I logic. I probably would like throw a dice. Yeah, that would be a good idea. Throwing a dice. Let us see if I'm able to find one dice in the toys that some little kids have over here. Thank you very much and have a good one. See you later. Bye.